talk of the day, you guys. I've learned so much and I feel super empowered. I hope you do too. And to wrap up our outstanding event, I'm here to welcome Beta Kochuner, Director of Machine Learning at Glassdoor. And Beta admits she fell in love with machine learning long before it was considered cool. And after a brief stint in academia, she sought to apply her skills in the retail e-com space, leading the roles at Amazon, Zilli, Facebook, and many others. And earlier this year, Beta left the retail space to focus on a brand new industry as a director of machine learning at Glassdoor. And she's here to talk about the less glamorous but still very complex reality of applying machine learning to real world business problems. And I'm sure we'll all have some great questions for her on that topic, so be sure to ping them in the chat. Welcome, Beta. Please take it away.
Hi, everyone. My name is Beata Kushner. I'm the Director of Machine Learning at Glassdoor, and I'm here to talk to you all today about applied machine learning, which is my field, and what I also colloquially refer to as research versus the real world. And first, I wanted to start talking a little bit about why I love machine learning, why I got into machine learning, perhaps why most of you also love it and got into it. Is just the opportunities and the advancement. And I've been in the field for almost 20 years now, and just the sheer progress and innovation that has been happening in the past couple of years, especially, in the past like 5 to 10 years, has been astonishing. So that's one of the things that is one heck of a motivation for me. And so, of course, like most of you, I follow, the news and the headlines quite a bit. And so some of the headlines that we've seen recently that's been super exciting that you probably also have seen is that Google trained a 1 trillion parameter AI language model. So we went from, order of million parameters to order of billion to order of trillion in what seems like less than a 5-year span. So that's extremely exciting. Then we have also Google made a model that's 1,000 times more powerful than BERT. So just like, 2-3 years ago, BERT was the most powerful language model. And now we have one that's 1,000 times more powerful. So that's amazing too. OpenAI's GPT-3 is producing billions of words a day. That's super exciting. My understanding is they're actually producing more words than any humans on WordPress combined. We have just recently news came out about a new chip cluster that will make massive AI models possible. So massive as in on this 1 trillion parameter scale. That's completely unprecedented. And also AI will help design chips in ways that human wouldn't dare. So that's quite a statement. So definitely surpassing human level intelligence in at least the area of hardware and the chip design. So as exciting as all of this is, most of us probably who work in machine learning, especially applied machine learning, know that this isn't really our everyday. And so these headlines that I don't think anyone actually wrote, but I could have written, and I'm sure most of you could have written, I believe might a little more accurately reflect our day-to-day, or at least it does mine. So something we've just had to deal with really recently in my company is that we just can't afford to train a custom BERT model because it takes several GPUs and several weeks to train. And so we continue using Word2Vec, technology that's about 7 years old now, which is stone age in for machine learning industry, but it's something that's very quick to train. So it takes 1 hour to train on a local machine versus several days on multiple GPUs that BERT does. And so that just works fine for us, and we just continue going with that. Other thing is logistic regression remains the most frequently used algorithm in production applications. That's probably the least exciting sentence that anyone in machine learning has ever typed, but it's still quite true, and it comes up, not just in our company, but whenever I talk to anyone from other companies, any interviews that I do, logistic regression is just what keeps coming up again and again. Another thing that happens, unfortunately, is state-of-the-art machine learning model fails to lift business metrics. So we often get really excited about the cool models that we can build, and based on the model evaluation metrics, it even does really well. And then we try to kind of replace existing business logic with it, and we try an A/B test. And the machine learning model either contributes absolutely nothing, or in some cases, it makes it even worse. Other thing is businesses struggle to find applications for non-factual generative models. So as great as it is that GPT-3 now generates billions of words, we have to remember that none of them are guaranteed to be true. And so for many, many business applications, it is of paramount importance that that whatever text is being generated is factual. And so there is not currently any model, I believe, on the market that can make that happen. And another thing that happens quite a bit to us, and I'm sure at other companies, is CEO excited to use deep learning balks at the amount of labeled data needed. So obviously, the people who are not, ML professionals still read those headlines from the previous slides, and they get very inspired and very excited about the potential of those applications. But when we actually break down to them what it would take for us to implement it, the excitement very quickly dies down. And so the topic really of this presentation is to talk about what machine learning is for most of us, and it's probably much less glamorous than it is, for the brilliant folks that work in Google research and Facebook research and OpenAI. But nevertheless, I believe it affects a really huge group of people, and so I think it's important that we discuss it. And so, as I mentioned before, time and money is one of the most important factors to decide on a strategy for machine learning and kind of what type of models to explore and potentially use in production. So current state of the art, they usually, if it's a company like aforementioned Google to OpenAI, they have billions of dollars at their disposal to play with those models. They have time. They don't necessarily have project deadlines per se. So they can afford both the money and the time to train those models. But for most companies that aren't those big companies, the cost is just at this point too prohibitive. And so we have to take that into account. And so for that reason, as I said, as I mentioned before, the logistic regression, because it works pretty well, it may not be working, state-of-the-art level results, and it's cheap and it's quick to implement, and most people understand it. So algorithms like that still prevail in the industry, even though they're technically not new anymore. They're not the state of the art anymore, but they're tried and true and they work. And so that's what wins. That's what tends to win in industry. Another thing that's very important is that business leaders expect a very quick return on investment, and they also don't expect to make a very huge upfront investment. And so it's very important to iterate and start super simple, start with the simplest approach possible, experiment with it, measure it, and then stop when the goal is not to have the most sophisticated machine learning model that you can, but the goal is really to have the simplest and most scalable and most cost-effective model that can do the job and achieve the objectives that we're trying to achieve. Another thing that's super important is data. So a lot of the papers that you're reading, they're trained on some benchmark data set, which is usually, it's used for competition. And it's a very important task to kind of compare performance and keep pushing the envelope and keep pushing the state of the art there. But those data sets are essentially already readily available to the researchers. So the researchers don't really have to be concerned with how to acquire this data. They might be concerned with the feature engineering pipeline, but the actual data and its quality and its implications are not so much of a concern to them as they are to ML teams in the industry. So in the industry, we're both constrained by data that's available at our company. So if certain data is not available and not being collected, there's nothing we can do with it. And sometimes even if we do have available data, there's certain regulations, for example, around personally identifiable information that we are not, that we end up not being able to use it. Another thing is that data, real world data is messy, it's inconsistent, it can be incorrect, and can have missing values, it can have duplicates, it can have staleness. Especially the duplicates issue is really hard to watch out for is that you might often have a different ID. So technically it will not be a duplicate, but if you're training a machine learning model and you have text data that is a duplicate, and you end up having the same type of text data in your training data as you would in your eval data, it essentially amounts to leakage. So you might have a model that really badly overfits, but still performs really well on the eval set, and you wouldn't really know, you wouldn't really catch it. And so we spend, it's already, I think, well known to all of us that that machine learning scientists and data scientists spend the majority of their time wrangling data, but especially in any kind of real world applications, it cannot be overstated just how important and how much time we spend on it. Another thing that is not really applicable in research, but is in industry, is that data comes from many sources. So we have data lakes, we have big data, we have Spark, we have relational data, we have Elasticsearch indices, all sorts of things. And so we need to build feature engineering pipelines, considering those are models that will need to be in production, and then the features will, the data will need to be transformed into features essentially in real time, or in whatever the SLA is that you have for your production model. The same will apply to features. So building a feature engineering pipeline is almost like a project in and of itself in most cases, which in research it's still necessary, but it doesn't require that kind of robustness. And another thing that often happens is that we realize, for example, if we really don't have the data out of the box that we would need to train the model to make the kind of predictions that we want to make, we need to involve humans in the loop, which is, manual labeling and annotation resources. And that's then another conversation to have with your business stakeholders and with your CEOs who are giving you the budget, is that the money doesn't just go towards the machine learning engineers and the hardware costs and the computational costs, but it also goes towards the human in the loop. And often it's also some complex tasks, and often those teams are remote, often they are distributed. So it's, for example, at Glassdoor, we have a person that full-time essentially manages data annotation and labeling. They work with several vendors and with several teams. So that's something usually a business leader who is thinking about making an investment in machine learning will not know off of the top of their head. So as ML leaders, that's something we have to get ahead of and make sure that that's understood and communicated properly. Another thing that kind of piggybacks off of data is the integrity, and it's kind of a term that I use broadly for kind of several different aspects. So, for example, research models, they are almost never used exactly in real-world applications. Like I do know that BERT, for example, Google does use BERT now in their search and production, but it's not the research team who built BERT who has to worry about deploying it in production. It's a different applied team. But for most models that aren't really used in production, so the concern is not that how it will potentially directly affect human beings. So some examples are credit risk models, like who do we give a loan to, and is a model biased towards certain demographics. Recruiting, I think there's been like a well-known snafu by Amazon where they had built a AI-based recruiting system and then had to pull it when they realized that it favors candidates with male names, traditionally male names, over candidates with female names. Something like security monitoring, right, like facial recognition, could be biased towards certain races, etc. So those are things that researchers don't really have to think about, but we in the industry have an ethical obligation. And there's also, I believe, currently some legislation potentially in development to regulate bias in AI models. So very soon it might actually be even a legal obligation and a compliance situation, like we did, more recently with GDPR, CCPA, that sort of thing. So we would just have to. It's not going to be even a choice eventually. Eventually, it's just going to be something we all have to do. Another thing that I kind of also consider integrity, I've touched on it before, like many language models, or all language models that I know of that are gathering the most kind of acclaim right now, they are built unsupervised on very large numbers of data and very, scraped corpus, I guess, of Wikipedia, of the book corpora, of all of the internet. And while it does allow them to create very natural sounding language and very human sounding language, their objective is not necessarily to create factual language. So it does not make any guarantees that what we write is factual. So I have just recently had a situation where a business stakeholder has asked me if we can use GPT-3 to generate programmatic rich text on our Glassdoor pages about employers, about certain jobs. And I had to educate them that if we do that, we would have no control over all of that information being factual. In the worst case scenario, GPT-3 could make up something about, this company's CEO was indicted for fraud or something that is not true, and then we would also be liable. So that's it essentially is, while it's a very hyped up model, you often realize that in many of your business use cases, it's still not ready to be used for that. Then we're getting to business value, which I've also mentioned before. Sometimes you build your best model ever and it still doesn't lift the business metrics that you want it to lift. And so obviously research does not really have to think about it. They only focused on the metrics such as precision, recall, F-score, or whatever the metric is for the benchmark that they're trying to optimize. And in the real world, we do have to prove business value because it is still, even though our companies are not investing billions of dollars into us, they're still investing a considerable amount of money into us with the need and the hope to see a quick payoff. And so even if we have really good evaluation metrics, we might have trained the model and it does really well in our evaluation test and our test set. We create an A/B test. We show the we use the model for the control group, for the test group, and the existing business logic for the control group. And sometimes we don't see a lift at all, and sometimes we even see a drop, and it's detrimental. And so some of the with the big takeaway from this is that this kind of testing, so whether it's A/B testing or any kind of experimentation, absolutely essential that any model is rigorously tested before any kind of full-scale adoption. So when you're having a split of 95 to 5% or 90 to 10%, even if your model does tank the metrics, it's still the damage is still somewhat contained, and then you can also stop a test early if it's doing really poorly. Whereas if you just roll out a model and just cross the fingers and hopes that does well, it could actually cost your company a lot of money in addition to what it costs to build the model. Finally, we'll get to deployment. So, excuse me, some water. So as I mentioned before, the research teams do not deploy the models that they build to production. There might be other teams within the company that do, but for them, they really just only care about building the model, optimizing its performance, its evaluation metric. And a production ML model is part usually of a really complex pipeline with both up and downstream dependency. So the upstream dependency would be the feature engineering pipeline that I've described before. So all of those things, if sometimes those things break or they don't finish in time, depending on the size of data, we've often run into where a pipeline that historically finished within a 24-hour period suddenly didn't when the amount of data grew. And that broke the entire pipeline. Then the model itself, needs some robust predictions, especially if it's a real-time, if it's an online evaluation model. We need to be within a certain SLA. We need to do a certain amount of retries. We can't have a single point of failure. Everything has to be unit tested and integration tested with any of its dependencies. So this is just something that when I came, and I had a little bit of an academia background, and this was one of the biggest shockers to me when I actually started doing machine learning in production, is just how involved that discipline is and how intricate and how many moving pieces there are. And another thing is that it is an illusion. There's still some business leaders operating under illusion. We'll build a small team of machine learning engineers or machine learning scientists, and they will just build and deploy the models end to end. That's just not how it happens in the real world. So in my experience, deploying a model and then to monitor it in production requires multiple teams. At the very least, you have data engineering involved to help you with the feature engineering pipeline. You have applied science who builds the model, who does the hyperparameter tuning. You have the ML engineering for these things that I mentioned above, all the production requirements and the testing and the dependencies. And then we have usually the DevOps for the deployment and for monitoring. And one of the things that almost never is discussed in research and almost always is a priority and a very important use case in the industry is concept drift. It's also referred to as data drift and model drift. So it's usually, refers to similar things. And so research models that kind of tend to be one and done. We have our nice, clean benchmark data set. We train it, we optimize it, we beat our competitors by, half of a percentage point in the F-score. We create a new state of the art. That's all really beautiful. But then we don't need to worry about it, or research does not really need to worry about it later. But really, some of the things that people, especially people who, your stakeholders who aren't necessarily ML professionals, tend to forget is that a model only knows, quote unquote, what it's been trained on. And so depending what it's been trained on, even models trained on data prior to January 2020 have absolutely no knowledge of the COVID pandemic. And especially in organizations where you deal with a lot of content like we do with COVID, like we do at Glassdoor, especially Glassdoor, for those of you who are not familiar, has a lot of user-generated content and user reviews of their workplaces and of their employers. And they will usually also rank it by certain aspects, right? We have a taxonomy of content. And so, for example, something like remote work may have been very niche before January 2020. It might have been like only a small percentage of our users have talked about it. And then suddenly, with things changing so quickly in January, February, and March, when then almost the entire tech world went to remote work, that became one of the main things that people talked about. And then, just a model that we may have trained even 2 weeks prior to the pandemic would have already been completely useless. And this is, in my understanding, like I said, this is the use case almost everywhere. So I can't even think of a single business use case where you can just build a model once and expect it to continue to provide business value if you don't touch it or if you don't evolve it. And there's several with drift. There's several monitoring techniques. Some are, statistical in nature and they can be automated. But a lot of the time you need, again, that human in the loop aspect that I mentioned before in the context of data annotation. There's also that context in model, in monitoring and drift detection. And so one of the kind of areas that I'm exploring right now that I still haven't mastered, and I would even be super grateful if anyone who's watching this presentation can, who has more experience on it, can connect with me later and give me some pointers. But how do we kind of automate everything that can be automated and deploy the human in the loop really strategically? Because like I said, the human in the loop is a very expensive resource. And to do that, to catch situations that happen like that. Another use case that we're experiencing, the labor market has obviously really kind of has blown up over the past couple of months with kind of the returns or the recovery. It has really bounced back. We're seeing kind of salaries going through the roof as well in certain professions, and especially Glassdoor also has some numerical, some salary models, some offer analyzer models. And those are the things too, where we can't just say, okay, let's just rely on historical data. What did a machine learning engineer make last year? Because that's almost completely irrelevant to what a machine learning engineer makes this year. So that's just some examples of how quickly the real world moves and the real world evolves, and just how inadequate kind of your one and done models are in that context. So just in conclusion, while obviously we're all super excited about ML and, and those headlines with the great innovations, I think there's still, I wouldn't want it any other way. I'm super excited about the innovation that happens here. what we do in our everyday jobs to make ML successful, to prove to our business stakeholders and to our CEOs that they're making a worthwhile investment, and to show them to that it's worth to continue investing in. The things that I discussed that I feel just aren't that very often talked about. We really need to we really need to evolve them. We really need to perfect them. There's still a lot of opportunity there that hasn't been explored. There's still a lot of things that even within my team that I'm leading, I don't feel we've mastered quite to the level that we would like to. So I hope this opens the discussion, like I said, to those of you, and it's probably most of us who are in ML, are in applied ML, to think about those things and potentially start being more vocal about them. And maybe use our platforms that we have, whether it's conferences like this one, whether it's LinkedIn, whether it's our company blogs, to just like put some more content out there and educate people more about what ML looks like, what applied ML looks like in the real world. So thank you all for listening, and I will take questions in the chat. Like I said, I love connecting with people in my industry. So if you would like to reach out to me on LinkedIn and connect with me on LinkedIn, or you have some thoughts, or you'd like to grab like a virtual coffee and shoot some ideas around, I would really appreciate that. So thank you everyone.